Alright, so here to reduce the overhead of using cross join, in cross join you have already seen that it is gonna multiply your outcomes with the row or original rows of your table, right? So we have here how many distinct outcomes here. We're gonna check which are not interested. By excluding not interested, there are, we have 3 distinct for outcomes, right? And the original data in our uh, table is, like, to check, just to check here, we have original data, okay, 6 into 3, we gonna get 18 rows for this. And just imagine if our data set expands and our original rows in the data in the fact table expands, then it gonna multiply with all possible combination of all outcomes using the cross join statement. It gonna be overhead for our query to process. Okay, so what we can achieve, how can we achieve this by using any other methodology? So here we have come up with an approach of using a full outer join with over distinct combinations, but here we are using cross join between our distinct call outcomes with the distinct student IDs, right? So if we have the student IDs, let's say if we have, we're gonna count, if we have student IDs 1, 2, 3 and 4, we have 4 student IDs, right? So only four rows, okay, so yeah, only 4 rows are gonna cross join with our core outcomes that currently has 3 rows. Okay, 4 into 3 is 12, so we are simply getting 12 rows here, and then we are full outer joining this with our original factor, right? This gonna reduce the overhead much more in an efficient way. So here you can see we are getting only 13 rows, and it gonna drastically improve your query's performance if the data expands in the future, right? And see, just see the query completion time here. It is, I think, 105. Okay, it is now 284 milliseconds, right? So if we check here, okay, now you are not gonna see the drastic change in the query completion time, but it will be seen if the data expands in the future. Okay, you can just simply assume this by just checking the number of rows here using this query and the number of rows using this query. Okay, so this gonna be overhead if you will be using cross join. Otherwise it can become more efficient if we simply do cross joining between the minimal data and then using full outer join, because the full outer join will just gonna bring all rows that are matching and nulls for those which are not matching. Okay, now what you should have a question that why do we need nulls here? These nulls are basically for those which are, for which there is no data present in our original table, for depending on this condition, the condition that we are wanna achieve, that if our original call outcome, okay, our original call outcome is equal to the distinct call outcome or not. Okay, so if there is match, then it is gonna give me that row, otherwise it will give the nulls. Okay, so with full outer join we are having that condition that our student ID should be matched and original core outcome should be equal to core outcome, otherwise it will show nulls. But for null we do have that the value of all those core outcome which are either present in the original core outcome or not present. So in that manner we can have we can replace that nulls with zeros in our aggregation while counting for our core outcomes. All right.